Hello dear students, very good morning to all of you. I hope you are safe at your place. Welcome back to the another session of computer organization and architecture. In the previous session, we have completed the concept of multiplexer. I would like to repeat that particular topic once again because my today's topic is based on the multiplexer only. Those students who have already understand the concept of multiplexer can forward the video, right? Because many girls told me that madam, you are repeating the previous concept for just for 5 minutes, right? But my today's concept is based on that only. At that time I want to repeat the previous session just for 5 to 6 minutes so that the current topic you can easily understand. So for such purpose I am majority of time repeating the previous session. So those students, they have already understand the previous concept may forward the video. Now multiplexer concept is nothing but it is many to one, right? Now see, there are two selection lines which can be used with the multiplexer. There are two types of multiplexer. One is referred as a time division multiplexing and frequency division multiplexing. Now time division multiplexing means what? You have working with a network, and in your network at a time there is only one device you want to share between the resources. So there is only one communication line which can be used for a specific time interval. So that is referred as a time multiplexing. And if you are working with a frequency, at that time again there are several devices which shares a common communication line to transmit the data. So that is referred as a frequency multiplexing. Multiplexer means there are number of input lines and one output line which can be activated at the time. So 2 raised to n input line is there and only one output line is there. Two more line we are going to use over here, which is referred as a selection line. So multiplexer is also known as data selector. So it is, what is the responsibility of data selector? It is responsible to select one of many number of input and it goes into the output. Multiplexer may be in the form of 4, 8 or 16 number of input lines. Here is the block diagram of 4x1 multiplexer. We have 4 inputted lines and 1 output line. So in this session we are going to perform opposite operation. So what we will do, only 1 input line and 4 output line we will draw. And again there are 2 selectors which can be used for the number of activated output line. So S0 and S1 we will draw with the demultiplexer. I0 to I3 is referred as a number of input line which goes inside AND gate. With AND gate we need to draw selection line S0 and S1 which is responsible to select particular AND gate. Output of each AND gate is inputted inside OR gate and finally single output is provided. Here is the truth table of 4x1 multiplexer. So with this we have used S0 and S1 as the inputter or selector. We have written logic over here. In the previous session A dash B dash I have used, which can be replaced with S0 and S1. If you already written in the book then it's okay, no need to make a correction because it is also same. As a output I0, I1, I2, I3, which is equal to variable A. This is the logic diagram of 4 by 1 multiplexer, in which there are 4 AND gates. Output of 4 AND gates are used as the input line of OR gate. Finally, you will get one output line because we have written 4 by 1 multiplexer. The line I0, I1, I2 and I3 is the additional line which you need to pass with the AND gate. The selector line S0 and S1 is responsible to select one input at a time, or to activate one input at a time. There are lots of fields in which multiplexers are used, and some of listed over here. Now let us begin with our today's session, which is based on the concept of demultiplexer. Multiplexer means many to one, so opposite of that is what? Demultiplexer, which means one to many. So how many input line we need to draw? Only single input line we need to draw with the multiplexer, and with that many output lines we need to draw. Multiplexer is used as a data selector because it selects data. Over here, demultiplexer is referred as a data distributor. Distributor means what? It distributes single data into the different number of destinations, right? So it is referred as a data distributor. Logic circuit which receives a single input line, and we have several output line, so we can say that it transmits the same data at different destinations. Over here we need to draw one input line, and we need to use 2 raised to n possible output lines. The decoder with the enable input can function as a demultiplexer. So whatever the circuit you have drawn with the decoder, the same circuit you need to use with the demultiplexer. See, with multiplexer also I have explained 2 correction of the circuit of decoder. Number 1, let me repeat it. Number 1, we need to pass I0 to I3 in each AND gate. And what is the second change? You need to draw OR gate over here. You need to combine input and you need to produce output. Now with the demultiplexer, what you need to do? You just need to pass one input line, one additional input line as a decoder. That I will explain later on when we learn logic diagram of demultiplexer. At that time I will explain this particular line. Here is the block diagram of 1 by 4 multiplexer. You can see that there is one input line which can be represented using variable A, and there are 4 output line which can be denoted using I0, I1, I2 and I3. Again, because it is multiplexer or demultiplexer, so compulsory you need to pass S0 and S1, which is nothing but it is a selector. It has one data input line which is used to transmit data. There are 2 selection lines, S0 and S1, and 4 output lines, I0 to I3. So this is the block diagram of 1 by 4 demultiplexer. Let us understand the truth table of 1 by 4 demultiplexer. Don't focus over here, right? When you see the lengthy point, at that time you may be may have fear that you are not able to write the given point, but don't worry regarding such. I will explain each and everything. You just need to listen carefully, nothing else. You can write the given points from the truth table only, but you need to focus on the concept. Now see, from the truth table you can understand that S0 and S1 are referred as an input variable. Y0 to Y3 are referred as an output variable. Each line is activated at a time. Y0 is activated when selection line S0 and S1 contains value 0, 0. So consider the first case in which Y0 equals to A. The value of Y1, Y2, Y3 are 0 for the first case. So you can write that output variable Y0 equals to A if S0 and S1 equals to 0, 0. What you need to do? You need to activate the first line and put 0 in the rest of the variables. Similarly, for the second condition, that is 0 and 1, for this particular combination, Y1 line is activated. So Y0, Y2 and Y3 output variables value is low. Low means 0. The third combination is 1, 0. So for this particular input of selection line, the third variable is Y2. So that is activated, or it produces high output. So for that, Y0, Y1 and Y3 are deactivated or low or 0. And for the last case, S0 and S1 contains 1, 1. At that time, Y3 is activated or it produces high output, and Y0, Y1 and Y2 are used to produce low output. Now let me read out these 4 points. What you need to do when I speak. At that time you need to focus on a truth table, not on the point. If you focus on a truth table, you can easily write the points, you can easily understand the point, right? So consider the first situation. When the value of variable A equals to 1. See, A equals to 1 means what? The line is activated or the output is high, or it is equals to 1. So 1 is there, or high value is there, or activation is there. That means it produces output. So when A equals to 1, selection variable S0 and S1 equals to 0, 0, then AND gate associated with Y0 gives high output. So this particular line is activated. High output means 1, or output Y0 equals to A. Over here Y0 equals to A. See, this is the reverse operation of multiplexer. With multiplexer, we have written A equals to Y0. Let me switch to the line. Output variable A equals to I0. Right? Instead of that, reverse operation we need to perform. Y0 equals to A. That means variable y, remaining variable name you need to write. Y1, Y2 and Y3 gives low output, that is 0. Similarly, again, if the value of variable A equals to 1, the selection line S0 and S1 equals to 0 and 1, in those cases, AND gate is associated with the variable Y1, which is responsible to produce high output, which can be written with the 1 or output Y1 equals to A. That means the remaining variable. So don't consider Y1 over here. So Y0, Y2 and Y3. All the three variable contains low output, that means 0. Now from the above 2 points, you can easily write the given next 2 points. How you can write? Again you need to write that when A is equals to 1. Remember that if A is not equals to 1, at that time line is not activated. So this is the must situation which you need to raise, that if A equals to A1, then only the particular output will be generated. If 0 is there, at that time output will not be generated. So this thing you need to keep in the mind, that your output is only high if the input is high. So for the high input, the line A equals to 1. So this is the must condition you need to have. So when A equals to 1 and selection input S0 and S1 equals to 10, then AND gate associated with Y2 gives high output, which means 1 or output Y2 equals to A. You can see over here for the combination 1, 0, that means for the third combination Y2 equals to A. Remaining variable Y0, Y1, Y3 are 0 or it produces low output. Consider the last situation or last case in which S0 and S1 equals to 1. Only if A equals to 1, at that time you will get the output. So in those cases, Y3 equals to A. That means it produces high output or output as a 1. So Y0, Y1 and Y2. This three variable produces low output, which can be represented using 0. So this is the truth table of demultiplexer, which is opposite of multiplexer. 4 by 1 multiplexer is there, 1 by 4 demultiplexer is there. Now let me share this slide of logic diagram of demultiplexer. See, in the starting of demultiplexer, I have told you that circuit of demultiplexer is same as the decoder, right? Let me share the logic diagram of decoder over here. See, this is the logic diagram of decoder, right? In which A dash B dash, A dash B, A B dash and A B. So you just need to copy this and you need to paste with the demultiplexer. But what you need to do, you need to give one activated line in each of the AND gate, right? There is no later correction regarding such. See over here D0, D1, D2, D3 is there. Similarly, we have used variable I0, I1, I2, I3. that is okay. Now see, over here a and b variable we have used. Instead of a and b, we have used selection line S0 and S1. One additional activated input line you just need to pass with each AND gate. That means A is passed with the first AND gate, the same cable you can attach with the second AND gate, the third you need to attach with the third AND gate, and the last cable you need to attach with the fourth AND gate. So the logic diagram of demultiplexer is same as the decoder circuit. What you need to do, you just need to pass additional activated line with the circuit. Now let me explain the last point. The decoder with an enable input can function as a demultiplexer. Over here you can see this is the enable input. This is the enable input lines or activated input line, right? So only you need to make a changes in the activated line. You just need to pass in different AND gate, nothing else. Now the applications of demultiplexer. Demultiplexer is used to send data from the single sources to the number of destinations. So when there is a requirement to pass the data in the from the single source to the destination, at that time demultiplexer is used. When there is a requirement of synchronous data transmission, synchronous means data would be there in the sequence. So when there is a requirement to pass data which is coming from the single source and it can be passed to the number of destinations, at that time you can use clock demultiplexer. That is a type of demultiplexer. How many types of multiplexer are there? Two types. Time multiplexer and frequency multiplexer. Similarly, we have clock demultiplexer which can be used with the synchronous data transmission system, which can be available in the receiver. Receiver means destination which receives the data. So over here with demultiplexer we have single source but many destinations. And when there is a security monitoring system, so with that also you can use demultiplexer. So in this particular session we have learned demultiplexer, which is opposite of multiplexer. Multiplexer can be used with the many to one. Demultiplexer means one to many. Multiplexer is working as a data selector. Demultiplexer can be used as a data distributor. Multiplexer type are time division multiplexing and frequency multiplexing. What is the example of demultiplexer? Clock demultiplexer. Over there, many sources, one destination with multiplexer. With demultiplexer, there is a single source and many destinations. Now, let us revise quickly our today's session. Demultiplexer means one to many. Generally, it is a logical circuit in which there is a single input line which sends into the several output lines. It is used to transmit the same data to the various or different destinations. As I have told you that it is also known as data distributors because it transmits the data to different destinations. There is only single input line and 2 raised to n output lines. You can use decoder by passing one input line, and it can be worked as a demultiplexer. Here is the block diagram of demultiplexer, in which we have passed one input line which can be represented as a variable A. There are 4 output lines which is represented with I0 to I3. There are 2 selection lines which you need to draw with the multiplexer or demultiplexer. From the truth table, you can write the given 4 points. At a time, only one output line is activated. An output line is activated based on the selection input lines. Logic diagram is same as decoder. You just need to draw one additional line which is represented with variable A. There is no changes in the circuit of decoder. You just need to draw one additional input line which is marked with the variable A. There are lots of applications in which demultiplexers are used. Here are the few of them. The first is when there is a requirement to send a data from the single source to the number of destinations. At that time you can use demultiplexer. We have clock demultiplexer, which is responsible for the data transmission and which can be installed inside the receivers. And it can also be used with the security monitoring system. So this is all about our today's session, which is based on the demultiplexer. In next session, we will understand the concept of register. All the concept you need to write in your book, so at the time of exam you can easily refer. Thank you all.